Question 2. X and Y are independent. What's the probability of X and Y? So let's make the chart. That would be probably the best way to go here. So the chart is, well, we have X, and then our values of X are 2, 4, 6, very original. And then we have probability of X. And we got 1/4, 1/3, and 5/12. Now the main thing to remember about this one is everything has, the probabilities here have to add to 1. So, must add to 1. Okay, we can get the second one for Y. So our Y distribution, our Y could be 10, 11, 12.
5.
I think that's supposed to be 15.
Ew.
That would change things, right?
Changes everything. Perfect one.
1/6, 1/3, a blank, and 2/5. And so again, this entire thing must add to 1. So this right here is going to be 1 minus 1/6 minus 1/3 minus 2/5.
Just make it all common denominator.
So however you want to do this, it's really your business. You will have a calculator. So I think this gives us 1/10.
Yeah.
1/10. Again, calculator this. Okay, so what's the probability that X equals 2 and Y equals 12? Well, they were told that we're independent. So if these two are independent, X and Y are independent, then we can just do the probability that X equals 2 times the probability that Y equals 12. And that will get us to us. That's 1/10 times 1/4, so 1/40th. Remember, you multiply if they're independent. Okay, so multiply if they're independent.
If it didn't say they're independent, then just add.
If it's
Not
disjoint, you add. If they're not independent, then you use, what is that? Probability of A times the probability of B given A. That's not independent. Okay. Questions on 2?
So if they're not independent, are you implying that they're disjoint, or
If they're not independent, they could be disjoint. They're not.
is it times or plus
Which one?
for the not independent?
Oh yeah, that's multiply.
Oh wait, so not independent, you still
use the equation.
Oh yeah.
Yeah. Okay, please. Okay. Don't have a lot of time, so let's have an organized discussion first, and then if you need some more discussion, I can give you some time. So organizedly, please. What else do we have, question-wise?
If they're disjoint, does that mean the common of A and B is 0?
Yes. If they were disjoint, that would mean that probability of X and Y is equal to 0. That's disjoint. Shall we move on, or are there more questions? Do you want time to discuss?
They said if they're disjoint, add them, but then if they're X and Y together, 0.
Oh shoot,
It's not confusing.
That's if it's or. You're right.
So,
Oh, I'm lost.
Disjoint and or means you add.
yeah.
Cool.
And independent and is you multiply.
Mhm. Not independent and, you use conditional. Or what did we call this?
Isn't disjoint technically not independent?
Disjoint technically is not independent.
But it's not independent.
Yeah.
It's disjoint.
What
What do you mean by use conditional?
This is getting bad.
This is conditional probability right here. Probability of B given that A has already occurred. All right. Let's continue with the next one.
Wait.
We're going to go to question 3. So question 3 says, consider the following set. Which observations are outliers given the 1.5 IQR rule? So we got to figure out how many observations are there. Well, maybe I should just write them all out, huh? So let's write them all out. What do we have? We have, can someone read them? 4, 5,
5, 12, 14.
I just don't know what that means.
14, 19,
14 isn't in this one.
Where's 14?
There's no 14. It's
14.
12, 19, 22. Trevor, did you color?
12, 19, 22,
22 again. Then 23, 28, then 28 again. 32, 32 again. 38, 49, 68.
38, 49, and 68.
Yeah.
Okay, so how many observations is that? 14, 1. So if there are 14, that means that our median is between the 7th and the 8th observation. 1, 2, 3, 4, 5, 6, 7. Oops. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so this is our lower half. And what we're looking for is Q1. So where is the middle data point in Q1?
19.
1, 2, 3, 1, 2, 3. So this is Q1. Where is Q3? 32. That one is Q3. So we need our IQR. That's 32 minus 19. Did someone calculate that? It's 13. Okay. And 1.5 times IQR? 19 and a half. Okay, so threshold for lower outliers are less than 19 minus 19.5. That's Q1 minus 1.5 IQR. So is there anything less than negative 0.5? No. None. How many high outliers? Any high outlier is greater than Q3 plus 1.5 IQR. 51.5? So do you have anything greater than, oh, right there, this one is greater than, that's definitely greater than 51.5. So the only outlier we have a high outlier is 68. I believe the answer key was wrong there. Gave you another value, which is kind of like this number turned upside down, right? 68 upside down is 89.
Oh, that's why the computer got it.
That's definitely why the computer got it wrong. I was thinking upside down. Duh. All right. Oh, Jude. Where did that go?
What happens to the high outliers?
Okay, what's next? The snapping turtles? Sorry, snapping turtle and a green turtle.
Do you want someone to read it?
Okay. Huh. Did you get the same IQ? Did you get the same,
If it's all multiple choice, as long as it's close, you'll be able to find an answer. Oh, yeah.
Alright, so for, what's the first one? Snappings?
Yeah.
So for snappers, mu equals 81, and sigma equals 6. For green turtles, sorry, I'm having trouble. Mu equals 142, and sigma is 14. Do you think these are real numbers? 142-pound turtle.
Yeah.
I don't mean to imply no. I'm just saying. I got these are from the interwebs, so I don't know. These are kilograms. So you have to multiply this by about 2.5 to get pounds. Wow. That's pretty big. That's like hundreds of pounds of turtle. Hmm? Are there cookies in the cookie jar?
Who, me?
Okay, so you want to know the mean of a snapper and a green put together distribution. So that mean is 142 plus 81. So that's pretty simple. That's 223, I believe. All right, and this is where on your test you kind of bonked it. The variance of S plus G, that's equal to the variance of the snappers plus the variance of the greens. So what's the variance of the snappers?
36.
The variance of the greens. 196.
Your square is the variance. And the variance is the square of the standard deviation. Bam. I forgot that minus. And the variance of the total is...
Alright, so what does this add up together? 232?
Yeah.
Yeah.
So sigma S plus G is equal to root 232. So whatever that is.
15.2.
Approximately 15.2. That should take care of that, right? Do you need a minute to discuss, or are you good?
We good.
You good?
We're so good.
Ooh, that was a good one.
That was a good drum break.
Being broadcast.
It is.
Hey people.
Hey, all you people.
Hey all you people.
Okay, 5.
Thank you. Thank you, Ramsey. Thank you.
Okay, so we're doing the rolling 2 dice problem, everybody. Okay, so this is the probability that the sum is 7 given that one of the dice, wow, shows a 6. Well, how many different ways can we get a sum of 7? a sum of 7. How many? What?
I saw you explain this today.
Sum of 7 is 1 6. I'm just going to list all the sum of 7s, okay? 2, 5, 3, 4,
You can get a 7.
4, 3, 5, 2, and 6, 1. Okay, these are all sum of 7. Okay. Now, it also tells, oh, sorry, let's go on to the next one. So we want to know how many different combinations have at least 1 6.
2.
That's 6, 1. 6, 2. Okay, now I'm not doing how many of these add up to 7 now. I'm saying how many of these, how many 2 dice combinations have at least 1 6.
So it's 2 out of the overall.
6, 3. 6, 4. 6, 5. Double sixes. 6, 5.
We already did 6, 5.
Oh, 5, 6.
Yeah, there you go.
4, 6.
1 6.
So all of these have at least 1 6. Okay. So now we want to know, now if you want to know the probability, we want to know the probability of a 7 given that there's 1 6. At least 1 6.
Oh my god.
Okay. All right, so how many have 7 and at least 1 6? Notice I'm doing the following. I'm doing the probability of 7 and 1 6. And then I'm going to divide that by the probability of at least 1 6. So what's the, how many of these are 7 and 1 6? That's this one and this one, and that gives me 2. What's the probability of getting at least 1 6?
11. 36.
There are 11 here, right? 1, 2, 3, 4, yeah, it's 11 out of 36.
Why is it out of 36?
36 possible 2 dice combinations.
Oh yeah, there's just 6 sides. Alright, that makes sense.
So then that's just equal to 2 out of 11.
This is 2 die. Each die is 2 die. So 6 by 6 with the 6.
Okay? Questions on number 5? Mhm.
So if I normally saw this like on a test, like how do we tell the difference that it's trying to tell us to do it like all the 6 combinations and do the 7? Because if I read it, I would just think like how you get a 7 with like a 6 in the combination. You know what I'm saying?
Yeah. I think the key phrase that I latched onto was given that.
Oh, you sneaky.
When you see given that, that means that you're holding a constraint. Something has to be true to qualify it. So if something has to be true to qualify, that's a conditional distribution, conditional probability. Okay? I feel like I'm using the wrong word. Is it really conditional, Abe?
What?
Is the word really conditional?
Yeah, the condition is that, yeah.
Okay. Yeah, all right.
What are other words other than given that?
If you know that, or if one of the dice. So it kind of gives you an if statement.
Is the
Oh, so by if you mean like it's almost like a scenario, like it's telling you.
Yes.
It's not saying this happened, but if it was to happen.
Yeah, they're giving you with a scenario that has to be qualified before you can do the probabilities.
So you gotta do some crazy.
Six. Pick up sticks.
That's what.
Six. All right, so quiz 1. So we got quiz 1. Okay. Miss Irina got 42. The mu was 32.
Is that the half?
Get that 1 second. The mu is 32 and the sigma is 10. Okay. So the x here, that's her score. So pretty good. Quiz 2. This time she scored 2 less points. She only got a 40. But the average was 35. Oh yeah. The class average went up, but the standard deviation decreased.
So she's still kicking ass.
She's still above the average, but we want to know which one did she do better on.
Obviously quiz 2.
So if we're looking at normality, so we have to look at the z-scores here. These are normal distributions, and just to make sure you don't make the same mistake you did on chapter 7, make sure you see the words normal distribution before you do anything. Normal means z-score.
If it doesn't say normal.
That is good to know.
Everyone has the same.
I'm preloaded on the phone.
I'm sorry, I don't have the...
I don't even.
So the z-score for the first quiz is 42 minus 32 over 10. That's equal to 1. So in other words, in the first quiz, she is 1 standard deviation above the mean. Quiz 2, she is 40 minus 35 divided by 3. What is that? 1.67 standard deviations above the mean. So which one is she better at?
2.
Quiz 2. So quiz 2. Oops.
And the z-score always 2 decimal points, right?
Quiz 2 has a better...
It's the z-score, yeah. If it's a percentage. It's a z-score.
Okay. Questions on this one?
Depending on how much they give you. If they give you 10, if they give you
Right, so I'm going to take a minute. I'm going to record it